Blocking a single protein could prevent nerve damage responsible for Alzheimer's, scientists find. They've identified a key protein in the development of Alzheimer's disease which could prove critical in slowing or even halting the condition's progress. The tests on mice, a research team led by University of Colorado pharmacologist Tyler Martinez, found that blocking a protein called murin double minute 2, MDM2, stopped the destruction of the protrusions or dendritic spines and junctions, synapses that is, and that aid communication between brain cells. This degeneration is triggered by the buildup of a substance called amyloid beta, which has long been linked to clogging up the brain in people with Alzheimer's. When MDM2 was deactivated, amyloid beta no longer had the same effect. When this protein, MDM2, is turned on inappropriately, it leads to pruning of the synapses when amyloid beta is present, says neuroscientist Mark Dell'Acqua from the University of Colorado. And we use the drug that inhibits MDM2 on the neurons. It completely, when we do that, completely block dendritic spine loss triggered by amyloid beta. So inhibiting this protein is clearly working. While a certain quantity of amyloid beta and the trimming of dendritic spines serve important functions in a healthy body, problems happen when they get out of control. Understanding the first links in that chain is likely to be crucial in understanding Alzheimer's. The neurological communications handled by dendritic spines and synapses are crucial in our ability to learn and remember, and in Alzheimer's, those functions are significantly impaired due to the breakdown in the brain's signaling. In this study, the experimental cancer drug Nutlin was used to limit MDM2 activity, which itself usually plays a significant role in tumor suppression. It's still early days for this particular area of research, but what the researchers have seen in mouse brains looks promising. This is an encouraging first step that gives us a new lead to pursue, Dell'Acqua said. And the next stage would be to see if the effects of inhibiting MDM2 really do slow Alzheimer's down. It's a complex and multifaceted disease, and while amyloid beta proteins are chief suspects in the hunt for the cause, there's not enough evidence yet for the conviction. Researchers continue to make new discoveries about how Alzheimer's gets started and goes on to impact the brain, and it's possible that the rest of the body is involved too, something that the team behind this latest study is ready to acknowledge. There are questions if anti-amyloid therapy is the be-all and end-all of Alzheimer's disease therapy, says Dell'Acqua. Even if you could tolerate the high cost and effectiveness, the effectiveness is questionable. We're saying that it may also be possible to intervene in the process by blocking some of the impacts of amyloid B, and you could intervene by targeting MDM2. The research was published in eNeuro and is by David Neild on Science Alert. Please leave your comments, and thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.